Okay, for today's lesson, we're looking at equations of motion. So we've looked at these different quantities a little bit before. We've looked at displacement. We know the symbol for that is S. We've looked at acceleration and time, A and T, and we've also looked at velocity, which we just had as V. Now, if we're accelerating, then our velocity is going to be changing because acceleration is a change in velocity. So we need to consider the initial velocity and the final velocity. So for initial velocity, we actually use the symbol U. Okay, so we've got these 5 variables and we've got these 4 equations that we can use, so that if we know like 3 of the variables, we can calculate one of the other ones using the equations. Now, this very first equation is a little bit different to the other 3. So this one we only use when there's no acceleration. Okay, so if we're not accelerating at all, we can just go straight to velocity is displacement over time. But if there is acceleration, we need to use one of the other 3 equations. Okay, so firstly, our general units, and I might just go back to this page. Generally, our units are for displacement, we have m, for velocity, meters per second, and this is on your formula sheet, the units, meters per second squared for acceleration, and seconds for time. Now, some people get a little bit confused about the -1 and the -2 and what's that all about. So I'll just explain that as well as I can. So for for velocity, we're talking about displacement over time, right? So the units for displacement is m, for time is s. So it's meters per second, yeah? So effectively what we're doing is we're just changing it from a fraction so that we've got everything on the top. So if you do maths methods and you've done a bit of indices, this will make more sense. Otherwise you might get a bit lost. Don't worry too much about that. But basically the s on the bottom is to the power 1, right? So if we wanted to move it to the top, it becomes s to the power of -1. So meters per second can be written in that way. Now, acceleration is velocity divided by time, effectively. So it's meters per second, right? So we get meters per second. So effectively, that's the same as meters per second squared. And we just move that to the top, so it's meters per second squared. So that's why we've got the little -1s and the -2s. Okay, so back to this. So we know that meters per second is generally the units that we use. Sometimes you get a question in kilometres per hour. If the entire question is in kilometres per hour and kilometres and hours, then you can stick with that. But if you've got some things in meters, some things in seconds, some things in kilometres per hour, you need to convert them all to the same unit. And generally, we always convert to meters and seconds. So if we get a question that has kilometres per hour and we need to convert it to meters per second, we divide by 3.6. Similarly, to go from meters per second to kilometres per hour, we multiply by 3.6. Now that's something that's not on your formula sheet, so you will need to remember that. So try and come up with a way to remember that. The 3.6 part, that sort of comes from 60 seconds in a minute and 60 minutes in an hour, and 60 times 60 is 3,600. So that's like 3/6. I always think kilometres per hour to meters per second. I think like kilometres are bigger than meters and hours are bigger than seconds, so it makes sense to divide to get a smaller number. So I don't know, that kind of works for my brain if you're trying to remember whether to divide or to multiply. Okay, so let's have a look at these examples. So converting a speed of 80 kilometers per hour to meters per second, we divide by 3.6. So we just go 80 divided by 3.6, and we get an answer of 22.2 meters per second. A velocity of 20 meters per second southwest to kilometers per hour. So meters per second to kilometers per hour, we times by 3.6. So it's 20 times 3.6, which is 72 kilometers per hour. And this one is a velocity, so I need to keep the direction. Okay. All right, now constant speed, no acceleration. So remember I said when there's no acceleration, we can just use the formula V equals S on T. So we're going to use that one. So what is the average speed of a runner who covers 42.195 kilometers in 2 hours, 16 minutes and 40 seconds? So if I want my answer in kilometers per hour, I need to take the number of kilometers and divide it by the number of hours. So I'm going to need to do some time conversion here. So first I'm going to turn the 40 seconds into minutes. So 40 seconds into minutes, we need to divide by 60 because there are 60 seconds in a minute. So divide that by 60 and we get 0.67 minutes. So therefore, the total number of minutes is 16 minutes plus 0.67. So we've got 16.67 minutes. Okay, I need to convert that to hours. There are 60 minutes in an hour. So divide by 60 and I get 0.28 hours. So I've now converted 16 minutes 40 seconds into hours. So the total time is 2 hours wrong number, 0.28. So that's the time in hours. So now I can get my answer in kilometers per hour. So the other version of this formula for the scalar version is speed equals distance over time. I write the full word for speed because if I just use S, you can get it confused with displacement. So speed equals distance over time. So the distance is 42.195 divided by the time, which I found was 2.28. Just getting a bit messy, sorry. And that gives me an answer of 158.2 kilometers per hour. Okay, now if I want that in meters per second, there's no need to do meters divided by seconds and calculate how much of everything I've got. I'm just going to do my conversion. So to turn it into meters per second, I need to divide by 3.6. So 158.2 divided by 3.6 is 43.9 meters per second. Okay, again, acceleration is 0 here, because it says so at the start of the question. How long will it take a cyclist travelling at 35 kilometres per hour to cover 2.5 kilometres? We don't have anything in metres or in seconds there, so I'm just going to leave it as kilometres per hour, and I'll get an answer in hours by doing that. So how long will it take? So I'm just rearranging my formula to get time equals distance divided by speed. All right, so the distance is 2.5 divided by a speed of 35. And I get 0.071 hours, which is fine as an answer. But I just want to make it slightly nicer, so I'm going to convert it to minutes. To convert to minutes, I'm timesing by 60, yeah, because there's 60 minutes in an hour. So that is the same as 4.3 minutes. All right, so that's those ones with just our minutes, meters per second, kilometers per hour conversions, and our acceleration is 0. Now we're moving on to questions where acceleration is not 0, so we need to use the other 3 equations. So, it's going to be annoying scrolling back and forth. So I'm using these 3 equations, and I'm following these steps here. So first I need to define a direction as positive, list the variables, write down all the values for the variables, put it into the equation, find your answer. Okay, so let's have a go. So first thing to do is define a direction as positive. Now if I read the question, her velocity is decreasing from 8 north to 4 north. So all I'm seeing in the question is north. So I'm going to say let's make a north positive. So I just make a little note somewhere, north positive. Okay. The second step is to write down all your variables. So that is, and I call these kind of questions SUVAT questions because that's what the variables spell out. So we write out our SUVAT. Okay, and then we fill in what we can. So we're decreasing the velocity from 8 meters per second. So originally we were going at 8 meters per second, positive because it's north. And our final velocity was 4 meters per second. So that's V. And we did that in 3 seconds. So that's T. What is her acceleration? So there is my unknown. Okay, so to do these, you need to know 3 things. And you know, looking for the other thing, right? So we're not interested in S at all. So what I do is I go back to my equations and I look for the equation that does not have an S in it. That's one I want to use. So this first one has no S, so I'm going to use that one. So V equals U plus AT. Okay, then I substitute in the variables that I've got written down. So 4 equals 8 plus A times 3. Okay, now we rearrange for A. So moving 8 to the other side, I get 4 minus 8 equals 3A. So therefore 3A is negative 4. So A is negative 4 divided by 3, which is negative 1.33. Now we need to interpret the sign. So we got a negative. We've said north is positive, so negative must be south. So my acceleration must be 1.33 meters per second squared south. Okay, and that's that one. Okay, let's try the next one. So same thing. I'm going to have a quick look. And it looks like I can see east a lot. So I'm going to go east is positive. Okay, and the next thing to do is to write out our variables. So there is SUVAT. And let's write in what we know. The cheetah increases its velocity from 20 kilometers per hour. So we started at 20. But you have to note here that's in kilometers per hour. That's no good, okay? Because the acceleration's in meters per second. We just want everything to be meters and seconds. So I'm converting that by dividing by 3.6, and that gives me 5.6 meters per second. We end up at 80 kilometers per hour. So final velocity is 80, and again I need to convert that to meters per second, which is 22.2. Now we're accelerating at 5 meters per second squared. I'm assuming that's east because the velocity is increasing. So we need to be accelerating east. So A is positive 5. Now how far did it travel? So that we want to know the displacement. So the variable we're not interested in is T. So I need to choose the equation that does not have a T in it. So I go back. The one without a T in it is the second one here. V squared equals U squared plus 2AS. Okay, so V squared equals U squared plus 2AS. Now, let's write in the values. So 22.2 squared equals 5.6 squared plus 2 lots of 5 times s. Now my 5s can look like s's, so sorry if that's confusing. Okay, now I'm going to put the 5.6 on the other side. So I get 22.2 squared minus 5.6 squared equals 2 lots of 5 is 10. So that's 10s. Now if I do that left-hand side in the calculator, I get 461. Oopsie, sorry about that. And that equals 10 seconds. So dividing through by 10 to get my displacement, I get s equals 46.1 meters. Now we can see I've got a positive answer, which means that my displacement is east. Okay, let's try the next one. Okay, traveling at 10 meters per second southward and we're accelerating at 4 meters per second northward. So we've got both a south and a north in this one. So I'm going to define north as positive just because that's what feels right to me. You can define south as positive if you really want to, it doesn't really matter. Okay, north, positive. And we write out, sorry about that, we write out our SUVAT and fill in what we know. Okay, an object travelling at 10 meters per second south. So our initial velocity is 10, but it's in the southerly direction, so negative 10. Accelerate at 4 meters per second north, so that's a positive acceleration of 4 for 5 seconds. What is the displacement? So S is our question mark. We're not interested in V this time. So what equation do I have that does not have V in it? Well, it's the last one. S equals ut plus half at squared. So we write that down. S equals ut plus half at squared and substitute in our variables again. So we've got negative 10 times 5 plus a half, 5 times, sorry, that should be a 4, times 5 squared. Okay, so negative 10 times 5 is negative 50. Half 4 is 2, so that's 2 lots of 5 squared, so 2 lots of 25, which is 50. So we get negative 50 plus 50, 0. So we get a displacement of 0. So that must mean that our object has ended up back where it started. How can that happen? Well, the object starts travelling south at 10 meters per second, right? But it's accelerating north. So that must mean that it's decelerating effectively. So it starts to slow down in the southerly direction until it stops, okay? Then, it continues accelerating north. So it's going to start to gain velocity in the northerly direction. So it's going to come back. And after 5 seconds, it ends up back at its starting point. So I'm just going to write that in words so that you've got something to copy down. And that's that. So have a read through that. Check that it makes sense. And the questions to practice on what we've covered this lesson are on page 17 of your physics questions book, and you can go through question 1 all the way through to question 16. You might like to do every second question, so then, before the test you can go through and do the questions that you missed. That would be fine, I imagine. And that is all for today, so please contact your teacher if you have any questions or need any help. Thank you.